Good afternoon. I had a very busy morning, so I'm a little late in getting us out this video, but it's coming either way. I'm going to start with this. We kick it off with one question I think that's coming up is for different problems. It's kind of like there's no consistent, always going to be one way or another. And this is what I mean by that. So there's this new introduction where you've seen like, oh, if we talk about a limit of one rotation, give all the answer, there's two answers, or just give one answer based on this limited domain, or give infinite answers in the form of plus blank times k. I want to explain that a little bit. I'm going to start with each of these. The sine curve, so all of these are periodic functions, as in they repeat forever. So really, and there will be infinite answers to the general trigonometry problems. Depending on the word problem or the physics problem you're working on, one answer may be the only one that makes sense. But so, for example, if you're basically say, when will the sine of a function be 0.5? Well, it's 0.5 there and back here and back here. And if we zoomed out, it's the sine of a function is 0.5 infinitely many times, right? But sometimes they also might say, if we limit that from 0 to 2 pi or 0 to 360 degrees, when is it 0.5? And that really comes up a lot because that's one full cycle, right? That's one full rotation of a circle. And you can see on the sine function that it hits that 0.5 in two places. And by the way, negative values are totally legitimate and kind of word problems or real life problems. Negative would refer to the past. So if something's rotating, over time, then you can talk about, oh, it was there a few minutes ago in the past. So answers where they've been saying, you've been finding two moments on the unit circle where this happens. It's one full rotation. However, I like to think of this. Now we've started to see some questions where there's just one answer, and they limit the domain to pi over 2 to negative pi over 2 to positive pi over 2. And let me just think of it this way. Your calculator, if you want to actually just have one answer for what is the arc sine of something, right? Which basically means like, what angle would be associated with the cosine of 0.5, which would be, or the sine of 0.5, which would be this, the answer would be this right here. If you limit the domain from negative to pi over 2 to positive pi over 2, notice we've hit every point on the sine curve. We've gone from the lowest low to the highest high. As soon as we go over here, those are just repeat values that we saw over here. And then as soon as we go over here, those are repeat values that we saw beforehand. So if you limit that to negative pi over 2 to pi over 2, looks like this, then that's what you're going to see in your calculator. If you get a negative result in your calculator, it's because for the sine functions, it's going to say, give me the one answer between negative pi over 2 and positive pi over 2. It'd be very nice if that were the same for all of these, but look what happened on the cosine. If we try to limit it to pi over 2, negative pi over 2 to pi over 2, what we have is all the positive values going up to the peak and going down. And they, except for the very peak, they all appear twice. And then we don't get any of the values of when it drops down to the lowest point. So instead, for the cosine, they say, well, if you start at 0 and go to pi, very similar. We've gone from the highest point to the lowest point. Everything after that is a repeat output, and everything before that is a repeat output. So for cosine, they limit this from 0 to pi for that exact reason. So if you restrict those domains, then you just create a singular output, which also makes it a one-to-one function, which helps us with secant and cosecant. Down here, tangent's very similar. It actually has vertical asymptotes at negative pi over 2 to pi over 2. So it becomes very evident on the tangent that it's just this repeated cycle that goes over and over again. So certainly if we keep our range from negative pi over 2 to pi over 2, then we've sort of hit one of these down to ups. And we've hit every possible tangent output. So hopefully that helps just explain why sometimes there's one answer, sometimes there's two answers, sometimes there's infinite answers. And this tangent function too, we could say, oh, this is 0.5 here, and here, and here, and here, and over here, and probably over here, and periodically just forever. Okay, so one more thing I want to talk about before I end this video is here is a problem from the end of 6.4, I think. It's about a Ferris wheel going around and around. Basically says that it shows that has an amplitude of 35. The reason this is a negative cosine function, by the way, is because of its starting point as you get on this Ferris wheel at the bottom. So a negative cosine function has that characteristic of starting at the bottom, and then it goes through this cycle over and over and over again. So this particular question, I believe, says, how long will it be that you are above 50 feet? And by the way, thinking about a full cycle on that, that would be a full rotation of a Ferris wheel going up to the top and back down. And if this is like one of those Seattle wheel situations where it's just a long one single rotation, that's the full ride is one rotation. This is when you get back out and it's sort of over. So this is an example of a real world problem where two solutions make sense because you do reach 50 feet on your way up and then you return to 50 feet on your way down. And if you get a negative solution, you might say, well, that doesn't make sense because I wasn't on the Ferris wheel in the past. I hadn't boarded yet. So it makes sense in the real world application to not consider negative values because they don't apply to what really happens. So this question, by the way, gets into how long will you be above 50 feet? And I just want to point out, just because this is a slightly different way of solving it, and I'm not going to get into detail, but instead of necessarily going into the unit circle and finding out on this cosine waves, when are the moment where are the two moments? If you just find the first moment, actually just using your calculator and solving this problem algebraically, subtracting 45, dividing by negative 35, taking the arc cosine of 2 pi over 3t, and then multiplying by 3 over 2 pi, then that will give you this first solution. But I just want to point it out. If you take the time to sort of draw this curve out, this, I feel, does a better job explaining what the answer means. And that basically means, what is this length of time from here to here, which is really a difference in two x values. And if you consider the fact that the period of this whole thing, this goes through one full cycle, and I think this is actually inappropriately graphed. This would actually be 3 right here, and this moment would be 1.5 right here. So scribble these out. Basically, if it's a 3-minute ride, which you can figure out using the period is going to be 2 pi divided by b. Our b in this equation is 2 pi divided by 2 pi divided by 3. Notice the 2 pi's cancel out. And if you multiply top and bottom by 3, the period for this just equals 3. Once you find this answer, another way, instead of going through this whole process of naming the angle u and doing this, these are equidistant to this peak moment here. Basically, after 1.5 minutes, you're at the peak of this thing. So the distance from here to here is going to be half the time that you're above 50 feet. So if you do find the solution, subtract it from 1.5, that's going to give you this distance. And then if you just double that on the other side, that's another way to solve this type of problem. Okay, the only other thing I want to plug right now, I'm going to switch my screen share, is just remember, really, I was going to go over a couple problems today, but they're all in this slideshow here. My colleague did a really good job creating these. I think this here, 6.5 is a good intro, but I'm kind of getting ahead to like this. This is one of the things we did in class yesterday was cover a problem very similar to this. But this video is just as good as a video I could make doing this. So I really want to just point out how excellent these slideshows are. And similarly, in 6.5, there's another video of a type of problem we did around the sun, the length of sun there is in a day. And I really think you should just check out those slideshows. They're really good. I find them super informative. So Anyway, that's what I got for you today. Reach out to me. I have lots of time tomorrow. We can meet over Zoom. Please don't be shy. Believe me, my in-person students are using my office hours and seeking help, so that I don't expect you would be any different. Have a good one, and maybe I'll see you soon.